Hello everyone, today is July 17th and this is the 10 a.m. class. This is class number 4 for our summer class. We have one more class next week on the 24th at 10 a.m. And what we did today is we started with decimals. So go ahead and write these down, and you probably should just follow along. We're going to name each of these and then write the decimals here. So if you were here for class, go ahead and push pause and do it on your own. If you want to see what we're going to do, just take a look, okay? So what we did today is we talked about naming things. This is, if you were thinking of money, and you know that I always tell you to think about money when you're dealing with decimals and such, this is 49 cents, okay? 49 cents, well, how many cents are in a dollar? Okay, and that's 100. So what this really means is this is 49 cents out of 100. Okay, so that's your fraction that you would write if it had asked you for a fraction. If we want to name this though, this is 49, so we're going to write that out. So 40, and it's hyphenated, so 49. And then we know it's 2 digits, which really means 100, 10th hundred. So this is 4900. So it's spelled like 100, and then put a THS on the end. Okay, that's the one we kind of hundredth, so that you can kind of sticks in your head. Okay? But if you make this into a fraction, you know right away that those are hundredths. Okay. All right, so what do you think the next one is? Again, if this was money, that would be 4 cents. So what that really means is we have 4 out of 100. Okay. So when we write the name of this, this is really 4 hundredths. The first spot is the tenths, then hundredths, and the next one, if it was there, was the thousandths. And again, the THS is at the end of that. Okay. The next one, okay, if this was money, this really would mean 80 cents, right? So that would mean 80 over 100. But we know now, we've done this enough, those zeros are going to cancel each other out. So your actual fraction is 8 tenths. 1 decimal spot is the tenths. And you can actually see that from working it out. So this would be 8 tenths. And your fraction would be 8 over 10. Okay? All right, so this one, 48 hundredths. If we just look at this part, we know, or 58 hundredths, sorry, we know this is 58. Okay, so we took care of this part. Hundredths means you need tenths hundredths. Okay, and so we're going to stick our decimal right in front. Okay, this one, 6 hundredths. Again, hundredths means we're going to have a decimal, tenths, hundredths. Okay, and I'm going to show you a trick with those dashes in a minute. So we need to fill 2 of these. This says we have 6. Now, if we put 6 here, that wouldn't be hundredths. Okay, let's say we did this. That would not be hundredths, that would be 6 tenths. Okay, and that's not what we were given. Okay, so it's not that option. So that means our 6 has to go in the hundredths spot. And we're going to put a 0 in front. So 6 hundredths is 6 pennies out of $1. Okay? Now, question for you. If I wanted to take this number and I want to round to the 10th place, what would I do? Okay. Well, that means I'm going to only have a decimal at one spot. But what is going to go in there? So what we do is we look at the 10th spot, okay, and we have to look over. If the number after it is 5 or above, ding, 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 all the alarms start going off. That means you're going to round up. So this will no longer be a 5, it's going to go up to a 6. And because we only want tenths, that's it. That's the end of the problem. Okay? And here you can see we're actually 6 tenths. That would be 6 tenths. Okay? Now, we also talked about the decimals, but we talked about the other side of the decimals and how these dashes come in to play. So let me show you that. All right, ready for a really long one. Okay, here we go. 10 billion 3,000 245. 145. Okay, there you go. Super, super, super long. So if you need to push pause and write it down, go ahead. Okay? All right, we need to get to the billions. Okay? Well, the billions, and I need 10 of them, which means we're going to have tens place and the ones place in the billions, comma. The next thing we would have would be the millions. Okay? They have hundreds, tens, and ones. Okay? Then we have the thousands. Again, hundreds, tens, and ones, comma. Now we have hundreds, tens, and ones. So I'll write that out. Tens, ones. Okay? Every time you move into a new group, you put a comma, which you can also see as it's written out in words. Okay? I like to do the dashes to figure out how many spaces I have to fill to write this number in numerals. Okay? To me, it's a lot easier to figure it out this way and then just put my numbers in. Okay, so that's a little trick. Okay, let's put our numbers in. So, we need 10 billion. So we need a 1 and a 0, and there's only 2 spots, so that's good. Okay. Millions. Are there any millions here? No, there's nothing. So what you're gonna do is you still have those spaces you have to fill, but there's 0. Okay. Now we have 3,000. Do we have any hundreds? No. Do we have any tens? No. Do we have ones? Yes, we have 3 of those. So that's going to go here, which means these still have a number in them. And they would be zeros again. Okay, they don't disappear. Now we have 245, so 2 in our hundreds, 4 in our tens, and 5 in the ones. Okay? Now, let's make this a little bit harder. Let's add to this and 75 thousandths. Okay, so there we go. Let's make it a little bit harder. Okay. The and stands for the decimal. So this is your and. Okay. Now, thousandths. So we have tenths, hundredths, thousandths. Okay, so again, put your dashes, figure out how many you need. Now we're going to fill in the 75. So we have 75, but we don't need all three. We have 75 thousandths, which means we've got a blank space. We again put in a 0. So this would be 10,03,245 and 75 thousandths. Okay? So that's quite a mouthful. Please start being careful with the and. We did a lot of decimal problems today, and I know it sounds like, why are we bothering with it? But we really do need to know how to read our numbers, okay? And a lot of times, I think because it takes so much to write this out, we just kind of ignore it, but we can't ignore it. We need to do it, okay? All right, so while you finish writing that, I'm going to get the next set up. All right, let's see here. The next thing we did was we compared some decimals. So 511 thousandths, and we're going to compare that to 52 hundredths. When you compare, so this is going to be compare, you're going to use greater than, less than, or equal to. Those are your choices, okay? When you compare these numbers, again, I like to think money. This says 52 hundredths, which means 52 cents, 52 out of 100. This is 511 thousandths. Now, even though there are more spots, more spaces, it doesn't mean that's 51 cents. If you cover that up, that's 51 cents and a hair bit, right? This is 52 cents, okay? That means even though this has more places, this is still bigger. So we're going to say that 511 thousandths is less than 52 hundredths. I have to think that one through a little bit, okay? So let's take a look at this one. 6 tenths and 3 tenths, okay? What do you think there? Okay. And again, this is like 60 cents. This is like 30 cents. So we'd all rather 60 cents. Let's find a little bit more difficult one. So this number, 893 thousandths and 938 thousandths. Okay. Which one, what happens? Okay. If you look at that, this is basically 89 cents, and this is 93 cents, okay? So I know that this one is smaller than this one, okay? Now, this one has thousandths. We don't have money that goes into the thousandths. So I want you to round to the hundredths on both of these, okay? So if you were to do that, I know I'm going to have a decimal in 2 spots, okay? The first number goes directly down. It does not change, okay? Because we're not looking at the 10th spot. We are looking here, okay? Now, to know what to do with my next number, I'm going to look over here and I'm going to say ding, ding, ding. No, I'm not, because 3 is smaller than 5, so we're not going to round up. We're going to just bring the 9 down. So we rounded down in that we got rid of those extra 3/1000ths of a cent, and we have 89 cents, 89 hundredths now. Okay. Same thing over here. The 9 will just come right down because we're not doing anything with that. We're looking at the 10th spot. I mean the 100th spot, sorry. So we're going to look over here. Are we hearing bells or no? Yes, you should be hearing ding, 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 because 8 is above 5, is bigger than 5. So this number has to go up. So it's no longer a 3, it is now a 4. Okay, and you can see easier that 89 cents is less than 94 cents. Okay. All right. Okay, here are our next problems, okay? Again, still working with the decimals. We're going to continue to work on that today. And you should be able to solve both of these with no problem, so go ahead and push pause and do that, and then come back and check it when you're done. Okay, so here we go. We are solving for x, that's our variable. We have to get everything over to the other side. Sophia said she likes to think about the chicken crossing the road. So this one's going to cross the road and get to the other side. Okay? To do that, we're going to do the opposite. The opposite of a plus 13 and 8 tenths is minus 13 and 8 tenths to both sides. Okay? That cancels out. We are left with x equals, okay, now we need to figure this out, 6 minus 8. Can you do it? No, we need to borrow. So we're going to borrow from the 5, it becomes a 4, and now we have 16 minus 8. That gives us 8. We bring down the decimal. 4 minus 3 is 1, and 1 minus 1 is 0. So x equals 1 and 8 tenths. Okay? Next one. What are we solving for? Okay, we're solving for y. We have to move everything to the other side. So the 10 and 5 tenths is going to move to the other side. To make it cross to the other side, you have to do the opposite. The opposite of a minus would be the plus. So we're going to add 10 and 5 tenths to both sides. Okay? Those cancel out, leaving you with y. Now, be careful here. This says 7 hundredths, but do we have anything in the hundredths spot? No. When you do decimals, you have to line them up when you're adding or subtracting. There's really a 0 there. So 7 plus 0 is 7. Okay? 3 plus 5 is 8. Because we've lined it up, we have our decimal. 4 plus 0 is 4. And 1 plus nothing is 1. So y equals 14 and 87 hundredths. Okay? Now, What if I wanted to round this to a whole number? What would this become? A whole number means I'm just going to have this spot here, but I still have to look over here. Are you hearing bells? Yes, you should be, because this is bigger than 5. So that's going to make this number go up. So if we were to round, it would be approximately, they're squiggly equals, that means approximately. It would no longer be 1, it would go up to 2. So 1 8/10 would round to 2. Okay. Same thing over here. What if I wanted to round this to the nearest whole number? Okay. That means here. Okay. I'm going to keep the 1. It's not going to go anywhere. But that 4, I have to look back at the 8, not at the 7, but at the 8. And are you hearing bells? Yes, you should be, because it's bigger than 5, it's greater than 5. So this number now goes up and it becomes 5. So 14 87/100 rounds to approximately 15. This means approximately. Okay, it's a squiggly and it means it's close to. All right, let's take a look at, let me find one that we did not do today. Did that one. I think this one is okay. 4 8/10 x equals 36. And we want to solve for x. Okay. So you should push pause, go ahead and work this out, and then come back and check your answer. All right, now that you've worked it out on your own, we know that we want to solve for x. We have to move 4 8/10 to the other side. It's got to cross the road. Okay, this says 4 8/10 times x. This is like those mom and dads. You're a teenager, it's time to separate. So we're going to have to do something more rough, not as easy as just adding and subtracting. We're going to divide. So we're going to divide both sides by the 4 8/10. All right, so 4 8/10 divided by 4 8/10 cancels out and leaves us with x equals. Okay, now this says 36 divided by 4 8/10. So who's doing the dividing? That's right, the 4 8/10 is doing the dividing, and we are dividing the 36. Okay, but we can't divide right away. If you have a decimal point under the division sign, no big deal. Just bring it right up, you're good to go. But if there is a decimal in your divisor who's doing the dividing, you have to get rid of it. To get rid of it, all we need to do is move it one spot over. But that means you have to do the same thing over here. Now, there's no decimal that we see because it's really right here at the end of the 36. So what we're going to do is we're going to move it one more, which means now we have to have the problem 360. Okay? So does 48 go into 3? No. So now remember, nothing can go there. It's already occupied, okay, even though it's not a number. Does 48 go into 36? Nope. So again, just remember, that's filled up, okay? I'm going to erase those later, but it's filled up. Don't forget that. The next number that's going to go here is right over here. Does 48 go into 360? Yes, that number has to go right here, okay? Now, that's kind of a tricky one. If it was 50, we would think 6, maybe 7 times. So I'm going to try 48 times 6, we'll try that first. 8 times 6 is 48. Carry your 4. 4 times 6 is 24. 24 plus 4 is 28. So that's not enough. So let's try 48 times 7. Okay, 8 times 7 is 56. 4 times 7 is 28. 28 plus 5 is 33, I believe. Yes. Okay, and that's bigger. Okay, it's still not as big as this, but we would, if we added 48 more, we would go over. So that means we're going to use 7. 48 times 7 is 336. Okay. I'm going to subtract. 0 minus 6 we can't do, so we have to borrow. That makes that a 5 and that 10. 10 minus 6 is 4. 5 minus 3 is 2, and that's 0. We compare, and notice 24 is less than 48. Now, we move this decimal here. Because there's a decimal, we can't say remainder 24. We can't put 24 over 48. No, we have to keep going because there is a decimal in this problem. So what we do is we add a 0. Okay. Now, we're going to bring down that 0. And now we have to figure this out. I hope I didn't just erase it. Let's try 48 times 5. I think 6 was too much before, but I don't remember. 5 times 8 is 40. 4 times 5 is 20, plus 4 is 240, which is what we want. So we're going to add in the 5, 240, subtract, we get 0. Okay? So x is 7 5/10. Okay? Now, we worked on one more type of problem. This was our challenge problem for the day. Actually, I think we did a couple more problems, didn't we? Okay, here we go. Let me find some examples that we haven't done before. Okay, so I'm going to erase this. Okay, so far we've just done one-step problems. So we're going to move to, let's see here, 3y minus 8 equals 16. Okay, so go ahead and try that one while I get the board ready. All right, you should have worked this problem out by now. You want to get the y alone. We're solving for y. The first thing we're going to do is get rid of those aunts and uncles. So we're going to move that minus 8, that negative 8, to the other side. It's going to cross the street, cross the road like the chicken. The opposite of a minus 8 is the plus 8. So to cross the road, we're going to plus 8 to both sides. Okay, the 8's cancel out. You're left with 3y equals 16 plus 8 is 24, but we're not done, okay? We still want to solve for y, okay, which means we have to get the 3 to the other side. Okay, to do that, this is the mom and dad. They're close, so we actually have to divide those because 3 times y, we have to divide. We do the opposite. We're going to divide both sides by 3. And that leaves us with y equals e. Okay, here's your next problem. As soon as you see parentheses, what should you be thinking? Okay. Yes, you should be thinking PEMDAS, but is this PEMDAS? No. Or distributive property. This is distributive property. We're distributing the 4 to each piece inside of the parentheses. Now what does that mean? That means 4 times the x, okay, keep your sign, minus, 4 times the 3, and it still equals 8. Okay, you need to take care of that first, and then you have to simplify. That gives us 4x minus 12 equals 8. Now you are right back to this type of problem which you can solve. Okay? So if you didn't remember this part, push pause and solve this. Okay. All right, we are solving for x. We're going to first move the aunts and uncles. They're going to cross the road and go back home. To do that, we do the opposite. The opposite of a minus 12 is a plus 12 to both sides. Okay. When we do that, those 12s cancel out. We're left with 20 on this side and 4x over here. We're still solving for x, so we need to get the 4 on the other side. Now remember, this is the mom and dad. They're real close, so we are going to divide them. So we're going to divide both sides by that 4. Okay, the 4's cancel out, and you are left with x equals 20 divided by 4, which is 5. Okay. So first we had to use distributive property, but once we've used that, we are just doing our normal problems that we've done many times. Okay, and then the challenge problem. All right, what challenge problem should we do this time? Okay, here we go. 2v plus 3 times the quantity 8 minus v equals negative 16. Okay? Push pause and work it out on your own. Okay? I'm actually not going to work this one out. Bring it in next week because you didn't have a homework assignment. So bring this problem completed next week. Okay? If you were here, we worked out a problem just like this, so follow the similar steps. If you weren't here, this one will help you do that one. Okay? So I will see you next week on the 24th at 10 a.m. See you then.